everyone. Today is December 13th, 2021. Now that's a new problem. The letter combinations of a phone number. Here is the Leetcode problem descriptions. Given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer is in any order. A mapping of digit to letters, just like on the telephone buttons, is given below. Note that 1 does not mapping to any letters. Examples here, digital 2, 3, so that's all output combinations. Example 2, nothing, that's return none. Example 3, so the digit 2, that's return the digit 2 present digits. The constraints is the digital lines will be 0 to 4, and the digit I just present from 2 to 9. So that means only characters. Okay. Based on this problem descriptions, I think I understand that's a classic brute force problem. Basically, on top of my mind, that would be the recursion resolution, recursion solutions. And so I'm thinking, so first one, let me check the functions. So based on the functions that give me return will be the 2D array, and the return size, and the input is a 1D array, the char array. And I'm thinking, so first one, I will have a function to calculate the return size based on the input array, and basically idea about input size will be how many digits of the input array. That means the length of the array. Uh, Thinking the performance of that function, I would not call the string length function from the C library, classic C library. So I would scan the whole input array and return the the combinations numbers, the size, the combination size, also return the length of input array. So that will be, I mean, faster than the call string lines directly. So based on the analyze the input numbers, I just know it's except the 9, I just I mean times 3. If that's 9, that's times 4. So whatever the number I got, I could calculate the return size. That's the first function. The basic function, major function will be letter combinations. That will do some initialize variables and calculate the size, and do some memory malloc. After that, that's called the recursion function to do that. So for the recursion function, I'm going to do just create a temp buffer to contain the combinations processing, and so that temp buffer size will be the length of the input array. And once I got a combination ready, I just copy that to the return to the array. And I also copy the temp. Actually, since that's no only the temp buffer, so I don't clear the whole temp buffer, just clean the 1 digits every return. So that will be save the time and faster. So now I'm going to do the coding. So let me copy the functions, and here is the code here. So I'm going to do this. As I said, the first function will be return the size, so the combine size, so it will be the input digits. Like I said, I also need return one thing, that will be the integer pointer for the size of array. So that will be the size length, will be make more sense. Okay, so declaration for the indicator calculator, so that will be the while. I'm thinking I maybe could using the length directly instead of. Okay, let's use this one, equals line 0 and while digits input arrays I also need handle the +1 here. Not equal the if digits. Okay, in that case I don't think I do minus plus is good idea here, but I do here. So digits length equals 39. That means I have return size the size times 4 else if digits length I would say I would do length. Okay, so no, I will double check input is better. So if digits length greater 032 and digits length indicator minus length equals 0.8, then that's right. So I just times 3 else print input digits is invalid. That's a print out. What's the what's the problem here? And the digits. Okay, here we go. So, and return 0 for the error. Else lines will be minus 1 or plus 1. Okay, and do the double check. Since the constraints said that the length, the input digit length will be 0, size 0 to 4. So if length greater than 4, then that means problem. So I don't return -1. So input digits length is invalid. I also need this one. So, and return -2 for the indicator. So, after that, once the loop is break, that means the length is ready. Since that's 0 index array and +1 happens just before a quit loop, so the size will be fine. So okay, and in that case return the size here. Okay, the first function is done. I'm going to implement the major function. So first one, I need the indicator for the loop. I also need the return to the array for return, and I also want temp, buffer, and one temp size, and one the string length. Okay, so basically I need a return size equals combination size for the digits and lines. If the length equals 0, just return size less than 0, just return none as result. Otherwise we are going to malloc. So that will be the return equals malloc the return size times size of char pointer. Okay, for I equals 0, I less than return size, and I'm going to initialize This time I'm going to call tag catalog to zero initialize the array, and the size will be the length and the size of char. Okay, here go. The return array to the array is ready. Return size is calculated down. Input array is there. Okay, I also need one thing. The temp buff malloc size char. Okay, the temp buffer is ready. So next time will be the last function for the recursion. This time I'm going to call make a void function, and I call that lighter combine recursion. Okay, first time I need a return one. I also need an indicator. Indicator will be index. Oh, so here I missed one for the index. Index, and I also need the temp buff and temp size. Temp size will be the input, so I don't need temp size here. I just need the temp size as input. So the input array, return array in global index for the return. Okay, I also need length. The input array length here, and the temp buffer. That's it. So let me see. So here, for the first time, I will handle the if length equals temp size. That means we are handling last digits. So loop indicator loop index. So I am going to do this. Okay, so for the string, I also need lines plus 1 for the string, and I also do need a length string for the terminator of the string. So in that case, length, the last digits So the last digits we need to check. Okay, fall. Okay. I'm thinking how do I tell to control the loop size for the last digits. There will be two cases, digit 2 to 8, and the second case we will digit 9. I am thinking. Okay, I have a trick to do that. For general, I just do 3, and yes, here we go. Index 0, 0, 3, and when the lines indicator less than 3, I do 1, 1, and here okay, so based on the characters, I would handle the index number of the characters. That's easier for me. So I'm going to Google the ask table, so I could handle this. Okay, I got ask table like this. I'm just thinking with the since that's 26 letters, I just using 26 mod 3 to get the value. And so with mod 3, I just did mod 3. Okay, mod 3 and plus the loop indicator. That's it. Yes. Okay, so for the letter, lowercase letter from A to Z, that will be the hex 61 to 78, 78, 61, 78. So let me mark down this in my codes. So I could write down. So the hex ASCII table, the A equals 061 and the Z equals 067A. So that will be that. I'm thinking if I need a function for that will be easier. Okay. Maybe I could do this. Okay, I need a function. So the input 叫that way I call that letter decider. Decider. Okay, that makes sense. Input just chart. Okay, just chart. Digits. Okay, that's easier. So int return equals this minus int if return equals not this. No, not like this. I return 3. So no. So that means I'm thinking. So okay. Okay, that makes sense. So just the tell if digit equals 9, then return return x y w x y z w x y z w x y z. That means if return the 77, yes, and else since we already checked the digits during the combination size functions, so we don't do the exception check here. So the else we just return 061 plus 3 times digits. Okay, so 2 digits 2, that means we need digit 2 minus 1 to considering the digit number 1, since that's no letters assigned to the phone button 1, and so that will be that one. Okay, so that makes sense. So starter. Okay, that's starter. Starter equals lighter decider and the digits. Oh, I'm missing the digits. So that means the char digits. Okay, digits length. So that tell me for. That means temp bath length equals starter plus I, then memory copy the return return index plus plus minus plus 1 and from temp buff and lines times size of char. Yeah, here we go. That's memory copy. And when that is done, I'm thinking if, let me make sure that's the right one. So here we go. So I'm missing one. So I'm thinking if I could, I need clear the return size 1. So yeah, for that return I don't need. I'm thinking if I need to temp buffer clear. Anyway, when I quit that one, okay, that's the one. Let me do the temp clean. Let's equals. No, I'm going to. That doesn't matter for here. I'm going to use this one, so I could reuse this lines of code later on. Okay, else that means I also need to have starter. Okay, starter, that's same thing. Starters. So I'm thinking if I could use this code as common. So since I will use that one as the temp size as is. So that would be the common code right here. Okay, so starter will be assigned. So the fall to copy this code also here and delete that one. So okay, so same code I could use here also. Okay, so then next step I'm going to recursively call this one. Okay, that will be return index digit length temp buffer and the time size plus 1. That's the point. Okay, so I do this one, I just curve. So, oh, okay. Okay. I didn't handle this. Okay, so let me do this. I didn't handle the digit 9, so let me do that later. After I quit that one, I'm going to reuse this code. Okay, so that's the one. Okay, here I need to handle if starter equals x. I mean the 077 Is that right? W, yes. Then and I equals equals 2. I think equals 2 will be the last one. So that means I need to handle these two lines again. Handles 2. 0, 1, 2. That's 2. 2. And I will do 3 this time. So, okay, that's 3. Yes. Yes. Let me copy this part to here to. Okay, if starter equals W, then I equals 2. That means almost the end. Okay, then I will do this one. No, not here, not length. Okay, not length. That's not good. So that will be temp size. Temp size, and call the recursion again. Okay, that's right. So, let me see. Yes, temp size. Okay, that's spell tempo. So, okay, here we go. So that's the one. So after that, the temp buffer will be cleared. The temp size buffer will be cleared. And now here, I'm going to copy this one to the major function. I call this one return is fine, index. No, index is not fine. We need a pointer here in digital lines, and we also need a 0 here. Okay, so the temp buffer, that's right. We do the catalog, that's right. Okay, after that, if the temp buffer, we just free it. And return to the array. Okay, it looks like I complete the code. Let me see. So we do 4 functions. One more, as we expect as original design, but that's fine. And the combined recursion, we call that. We handle the digital 9 here. We hold it. Maybe I could add some. Handle digit 9. Okay, that's the one. So I think I did the brute force in the recursion. That's maybe the fast way. That's so far currently I have the fast way I could think. But let me think. We cannot use the backtrace because all the case will be needed. We don't have any condition to tell that combination is fail or not. We just need all the combinations. Okay, that's it. Okay, I know that's a very long very long presentations. Thank you for watching and your patience. I'm still getting better, I think. Thank you. You had a good one.